This is B. Ramarao from SRRS Government Polytechnic, Siricilla. We discuss Diploma First Year Student for first semester Common Subject General Chemistry C104. Our topic is solutions. Objectives. On the completion of this period, you will be able to know solution, types of solutions, mole concept, calculation of mole. On the completion of this period, you will be able to know what is a solution, how many types of solutions, what is a mole, how to calculate the mole given component. These are discussed in this hour. At the completion of this period, you will be able to know what is a solution, how many types of solutions, what is mole, how to calculate the mole given component. These topics discussed in this hour. In the completion of this period, you will be able to know solution, types of solutions, mole concept, calculation of mole. What is a solution? Solution is a type of homogeneous mixture that is made up of two or more substances. That is made up of two or more substances. Solution is a type of homogeneous mixture that is made up of two or more substances. A homogeneous mixture is a type of mixture with a uniform composition. Solution is a type of homogeneous mixture. Two or more components mixing each other then form a single layer of component is called homogeneous mixture. Like water mixed with salt. Those two different components mixing to each other then form a uniform composition is called homogeneous mixture. This water mixed with salt. These two components does not mixing to each other, they form two different layers. One is salt component layer, another one is water layer. This type of mixture is called heterogeneous mixture. So water is a type of homogeneous mixture that is made up of two or more substances like salt, water, salt plus sugar, two or more components mixing to each other then form a uniform composition is called solution. Solution is a type of homogeneous mixture that is made up of two or more substances A homogeneous mixture is a type of mixture with a uniform composition. Let's make use let's make use of our salt water. Salt water already we discussed homogeneous mixture. Let make use of our salt water example. To talk about the two main parts of solution, these are solution made by two different components. One is water and one is salt. Then form a uniform layer of homogeneous mixture is called solution. Let's make use of our salt water example to talk about the two main parts of a solution. There are solute and solvent. Solute and solvent. This is the substance that makes up the minority of the solution. Minority of the solution, or this is the part that is dissolved. Example, the salt water, the solute is the salt. Solute. This is the substance that makes up the minority of the solution. Or this is the part that is dissolved. That is dissolved. Example, the salt water. The solute is the salt. In homogeneous mixture made by two different components of salt and water, which component present less quantity in a solution is called solute. So in this solute is a salt. Salt present less quantity in the solution is called solute. This is the substance that makes up the minority of the solution, or this is the part that is dissolved. Example, the salt water, the solute is the salt. Solvent. This is the substance that makes up the majority of the solution. Makes up the majority of the solution. This is the part where the solute is dissolved. Where the solute is the dissolved. Example, the salt water, the solvent is water. This is the substance that makes up the majority of the solution. Makes up majority of the solution. This is the part where the solute is dissolved. Example, the salt water, the solvent is water. Solute and solvent. In a solution, the maximum quantity of the substance or large quantity of the substance present in a solution is called solvent. This is the substance that make up the majority of the solution. This is the part where the solute is dissolved. Example, the salt water, the solvent is water. Because value is temperature dependent, molarity can changes with temperature. A homogeneous mixture of solution present two substances, one is solvent, another one is solute. In a solution which component present less quantity is called solute. In salt water, salt component is very less quantity present in water. So salt is solute particles. In a solution, the component present large quantity is called solvent. Salt solution, the water present more quantity than salt, so water is act as solvent. Types of solutions. Types of solutions. Solutions are three types on the basis of physical state solutions. Physical state solutions are three types. One is gaseous solution, second one liquid solution, third one solid solutions. Gaseous solution, liquid solution, solid solution. In gaseous solution, gas can spontaneously maximum in a proportion. Gas solution, the gas component present large quantity in a solution is called gaseous solution. This gas component is act as solvent particles. This gas component act as solvent in other solutions are called gaseous solutions. These gaseous solutions are three types. There are gas in gas solution, liquid in gas solution, solid in gas solution. Gas in gas solution, liquid in gas solution, solid in gas solution. Gas in gas solution. For example, air. Air present mixture of gas components nitrogen and oxygen. Liquid in gas solution. For example, water vapor or moisture. These liquid particles of vapors present in air. Example of liquid in gas solution. Solid in gas solution. For example, dust particles, smoke particles present in air. These are gaseous solutions are three types. Gas in gas, liquid in gas, solid in gas. Second one, liquid solutions. Liquid solutions are the most common and they can be obtained by dissolution of a gas, gases, liquids or solid solutions. These gaseous solutions are the most common. They can be obtained by dissolution of gas, liquid or solid solution. In liquid solutions, liquid component act as solvent. In the solvent mixed with gas particles, liquid particles and solid particles, present solutions are called liquid solutions. These liquid solutions are three types: gas in liquid solution, liquid in liquid solution, solid in liquid solution. These liquid solutions are three types: gas in liquid solution, liquid in liquid solution, solid in liquid solution. Gas in liquid solution, for example, soda water. In soda water mixed with gas component of CO2, these components act as solute particles, solvent particles of water. This water component is large quantity, so this is liquid solution. Soda water is example of gas in liquid solution. Liquid in liquid solution. For example, alcohol solution. Alcohol mixed with water, so both are liquid stage. Third one, solid in liquid solution. For example, salt water. Salt present in solid state, water present in liquid state. These three types of liquid solution: gas in liquid solution, liquid in liquid solution, solid in liquid solution. Third one, physical state solutions are solid solutions. They are generally called alloys. When two or more metals are present, mercury alloy called as amalgam, and they can be liquid or solid. They can be liquid or solid solution. These solid solutions are three types: gas in solid solution, liquid in solid solution, solid in solid solution. Gas in solid solution, liquid in solid solution, solid in solid solution. Gas in solid solution. For example, hydrogen gas in palladium. These palladium metal particles act as solvent. The solvent particles act as solid state solutions are called solid solutions. Gas, hydrogen gas present in palladium. This is gas in solid solution. Second one, liquid in solid solution. For example, amalgam. Sodium amalgam. Sodium mixed with mercury. Sodium amalgam. Third one, solid in solid solution. For example, alloys like brass, bronze, nichrome, German silver. These are all alloys. Another one is the relative amount of solute and solvent solutions are three types. Those are saturated solution, unsaturated solution, supersaturated solution. The relative amount of solute and solvent solutions are three types: saturated solution, unsaturated solution, supersaturated solution. Physical state solutions are three types. Those are gaseous solution, liquid solution, solid solution. The relative amount of solute and solvent solutions are three types: saturated solution, unsaturated solution, supersaturated solution. Saturated, unsaturated, supersaturated. Now we discuss supersaturated solution. A solution that contains a relatively large amount of solute then that required per saturation. It is prepared by heating and adding more and more solute. A solution that contains a relatively large amount of solute then that required for saturation. The maximum amount of solute particles present in a solution is called saturated. It contains more amount of saturated solution of solute particles of solution is called supersaturated solution. It is prepared by heating and adding more and more solute particles. More and more solute particles by adding a solution is called supersaturated solution. This supersaturated solution prepared by heating by adding solute particles more than saturation. A solution that contains a relatively large amount of solute then that required for saturation. It is prepared by heating and adding more and more solute. It is adding more and more solute. Dilute solution. A solution containing relatively small quantity of solute and as completed with the amount of solvent. A solution containing relatively small quantity of solute as compared with the amount of solvent. Concentrated solution. A solution containing large amount of solute in the solution than that in dilute solution. A solution containing large amount of solute in the solution than that in dilute solution. A solution containing relatively small quantity of solute as compared with the amount of solvent. A solution containing large amount of solute in the solution than that in dilute solution. Unsaturated solution. A solution in which more solute can be dissolved. More solute can be dissolved at a given temperature is called as an unsaturated solution. Unsaturated solution means a solution in which more solute can be dissolved at a given temperature is called as an unsaturated solution. A solution in which more solute can be dissolved at a given temperature is called as an unsaturated solution. Mole. Mole is a measure of the amount of particular in matter. It is the chemical dozen, chemical units. Mole is a measure of the amount of particulars, particles like atoms, molecules, particles in matter. It is the chemical units like mole is always represented by Avogadro number 6.02 into 10 to the power of 23. 6.02 into 10 to the power of 23. 1 molar mass of any substance contains 1 mole of particles. 1 molar mass of any substance contains 1 mole of particles, ions, molecules, atoms, etc. Mole, that is equal mass or molecular mass. Number of particles, Avogadro number. Example, 1 mole of aluminum is equal 6.02 into 10 to the power 23 atoms. 1 mole of aluminum 6.02 into 10 to the power 23 atoms. Lorenzo Romano Emilio Carlo Avogadro. Lorenzo Romano Emilio Carlo Avogadro is a scientist. D. Quarangina D. Serito. Count of Quarangina and Serento was an Italian scientist. Is most noted for his contribution to molecular theory, including what is known as Avogadro's law. Avogadro's number 6.02 into 10 to the power of 23 is Avogadro's number, equivalent to 1 mole. 1 mole. Mole is a measure of the amount of particles in matter. It is the chemist dozen. Mole is always represented by Avogadro number 6.02 into 10 to the power of 23. Mole, that is equal mass, molecular mass, number of particles, Avogadro number. Any 1 mole of aluminum 6.02 into 10 to the power of 23. A mole is simply a unit of measurement. Mole is simply a unit of measurement. Units are invented when existing units are inadequate. Chemical reactions often takes place at levels when using grams would not make sense, yet using absolute number of atoms, molecules, ions would be confusing too. So how much is a mole? A mole is the amount of a substance which contains the same number of chemical species as there are atoms in exactly 12 grams of the isotope carbon 12. In short, 1 mole is equal to 6.02 into 10 to the power of 23 particles. This is called Avogadro's constant. More on him in a second. The mole is a SI units with the symbol MOL. The word comes from the Latin for heap or pile. A mole. A mole is the amount of a substance which contains the same number of chemical species as there are atoms in exactly 12 grams of the isotope carbon 12. In short, one more 6.02 into 10 to the power of 23 particles. This is called Avogadro number. One mole is a SI units with the symbol of MOL. Molar mass of water. Water H2O contains two atoms of hydrogen and one atom of oxygen. The relative atomic mass of hydrogen is 1.01 grams. The relative atomic mass of oxygen is 16 grams. So, molecular weight is equal to 2 into 1.01 plus 16, that is equal 18.02. Remember error propagation. Is this answer correct? Yes. When adding, you look at the number of decimal places. Water contains two atoms of hydrogen and one atom of oxygen. Atomic weight of hydrogen 1.01 and oxygen 16 grams. Therefore, molecular mass or molecular weight of water is equal to 2 into 1.01 plus 1 into 16, that is equal to 18.02. So, how do you calculate the number of moles? Number of moles is equal weight of the substance by gram molecular weight of substance. Mass of the substance by molar mass M. Weight of the substance by gram molecular weight of substance. Therefore, number of moles small n is equal weight of the substance by gram molecular weight of substance W by GMW or mass of substance M by molar mass small m by capital M. Molar mass is the collective name for atomic mass and molar mass. Helium has atomic mass, water has molar mass. Problems, for example, determine the number of moles of CO2 in 454 grams. Determine the number of moles of CO2 in 454 grams. How many number of moles present in 454 grams of CO2? Solution. First, look at the atomic mass of carbon and oxygen for the periodic table. The atomic mass of carbon 12.01 and atomic mass of oxygen 60. By periodic table, atomic mass of carbon 12.01 and the atomic mass of oxygen 60. The molar mass of CO2 is 1 carbon, 2 oxygen. 1 into 12.01 plus 2 into 60. 12.01 plus 32, that is equal 44.01. 44.01. Thus, 1 mole of CO2 weight 44.01 grams. The relation provides a conversion factor to go from grams to moles. Number of moles is equal mass by molar mass. Mass of CO2 454 grams by 44.01 grams. Answer 10.3 moles of CO2 present in 454 grams. 10.3 moles of CO2 present in 454 grams weight of the substance. Using Avogadro constant, we know how to calculate the number of moles in a substance, but what do we do with that information? We use it along with Avogadro constant to find the number of particles in a substance. Number of particles n is equal number of moles into Avogadro number. Therefore, capital N is equal small n into Avogadro constant L. We know how to calculate the number of moles in a substance. But what do we do with that information? We use it along with Avogadro constant to find the number of particles in a substance. Number of particles n is equal number of moles into Avogadro number. Therefore, number of particles n is equal number of moles into Avogadro constant 6.02 into 10 to the power of 23 particles. Therefore, Avogadro constant calculated by using 6.02 into 10 to the power of 23. We know how to calculate the number of moles in a substance. But what do we do with that information? We use it along with Avogadro constant to find the number of particles in a substance. Number of particles n is equal number of moles into Avogadro constant. Therefore, number of particles n is equal number of moles into Avogadro number. For example, calculation of number of particles. Calculate how many moles are present in 3.00 moles of H2O. Calculate how many number of moles or molecules are present in 3.00 moles of H2O. How many number of particles present in given number of moles. Calculate how many molecules are present in 3.00 moles of H2O. Given data, number of moles 3.00 moles, Avogadro number 6.02 into 10 to the power of 23. What is asked? Number of particles n is equal how much? Calculate how many molecules are present in 3.00 moles of H2O. Given data, number of moles n is equal 3.00 moles. Calculation of by using Avogadro number 6.02 into 10 to the power of 23. What is asked? How many number of particles n? Number of particles n is equal number of moles into Avogadro number. Number of particles n is equal number of moles into Avogadro number. What must be substituted? Therefore, number of particles is equal number of moles 3.00 into 6.02 into 10 to the power of 23. Therefore, what answer did you get compared to mine? Therefore, number of particles is equal 1.81 into 10 to the power of 24 molecules. 3 moles of H2O present 1.81 into 10 to the power of 24 water molecules present. 3 moles of water present 1.81 into 10 to the power of 24 particles or molecules present in water. Therefore, once again we repeated our problems. Determine the number of moles of CO2 present in 454 grams. First, look up the atomic mass of carbon and oxygen from the periodic table. The atomic mass of carbon 12 grams, that is 12.01 grams, and atomic mass of oxygen 16 grams. The molecular mass of CO2 is equal 1 carbon plus 2 oxygen. 12.01 plus 2 into 16, that is equal 44.01. Thus, 1 mole of CO2 weighs 44.01 grams. The relation provides a conversion factor to go from grams to moles. Number of moles N is equal mass by molar mass. Therefore, number of moles is equal 454 by 44.01, that is equal 10.3 moles CO. Using Avogadro constant, we know how to calculate the number of moles in a substance, but what do we do with that information? We use it along with Avogadro constant to find the number of particles in a substance. Number of particles N is equal number of moles into Avogadro constant. Therefore, number of particles N is equal number of moles small n into Avogadro number capital L. Therefore, capital N is equal small n into L. For example, calculate how many molecules are present in 3 moles of H2. Number of moles of H2O 3 moles. Avogadro number 6.02 into 10 to the power of 23. What is asked? Number of particles. Therefore, capital N is equal small n into L. What must be substance? N is equal to number of moles 3 moles into Avogadro number 6.02 into 10 to the power of 23. Then answer N is equal to 1.81 into 10 to the power of 24 molecules. 3 moles of water present 1.81 into 10 to the power of 24 molecules are present in a water. So, calculation of Avogadro number by using how many number of molecules present given number of moles of substance. Then 3 moles of water present 1.81 into 10 to the power of 24 molecules. 454 grams of CO2 present 10.3 moles of CO. 454 grams of CO2 present, number of moles 10.3 moles of CO2 present. So by using Avogadro number, calculation of number of moles and also using how many number of particles present given substance. So this is our today topic. In this topic we discuss what is solution, what are the components present in solution, how many types of solutions, physical state solutions, relative amount of solute and solvent solution. Physical state solutions are gaseous solution, liquid solution, solid solution. Relative amount of solutions are saturated solution, unsaturated solution, supersaturated solution. Avogadro number. Avogadro number of particles present in a substance is called 1 mole. That number 6.02 into 10 to the power of 20. This Avogadro number by using a unit volume of substance in chemistry. This number using how many number of particles present given substance and also how many number of molecules given number of moles of substance. These two are calculated by using Avogadro number. Thank you once again.